yeah, try to be brief here. So I sailed on merchant ships for about 18 years and then worked in management of various types of ships. So the most common type of ship you'll see here in the Portland area is bulk ships. They're dry bulk carriers. They're here to load grain. Majority of the ships, or the grain comes down the Columbia. Actually, I think you take barges as far up the Snake River. So the grain comes from eastern Oregon, Washington, and Idaho. Comes down in barges, so from those areas. The Columbia is only navigable for deep water ocean-going ships up until the I-5 bridge here in the draft that the Army Corps of Engineers maintains is about 43 feet up the Columbia River. Beyond the I-5 bridge, down to about 24 or something like that. So you'll only see barges going upriver beyond the I-5 bridge. Let me see. Bulk carriers, relatively simple ships. I'm thinking of making this into a bulk carrier, so I can use this. Typically, they'd have 5, maybe 7 cargo holds. So you have a transverse bulkhead separating the holds. Each hold would have a cargo hatch. Covers on top of a coaming that comes up about 4 or 5 feet off the deck. And hatches open and close with electricity, with wires, or hydraulically. Hatch covers are very important. Maintaining the watertight integrity of the hatch cover is primary responsibility for the ship's crew. You start getting water into the holds, you're creating possibly a list, you're reducing the amount of freeboard, so it's not a good thing. Typically, you'd see on a bulk ship that's up here that carry about 40,000 tons of cargo. And for propulsion, they'd have a single diesel engine coupled to a fixed propeller, most likely not a controllable pitch propeller or anything fancy. And slow speed engine turning about 85 RPM at top speed. Ship would probably make about 15 knots out at sea. And so the reason some people, you might look at a ship and say, oh, it's 600 feet long, 40,000 tons. Why doesn't it have a bow thruster or something special like that? Bow thruster is located up forward on bow. It's a tunnel with a propeller in it. And you'll see them on some ships, like passenger ships, have all kinds of fancy bow thrusters and thrusters because they're docking on a regular basis, daily in some cases. But on a large commercial ship, spends so much of its time at sea, you don't want any resistance to the water flow. You want a smooth hull. So I probably wouldn't put a bow thruster.
You're going to do a bow thruster on the shell back?
No.
You could hire cubs.
Get some friends to pull the line, push it out. Okay, so yeah, ship, like I said, making 15 knots. You'd have a crew, maybe 22, 24 people on it. Not a lot of people on a bulk ship. Typically, these ships are foreign flagged. They'd be registered in countries like Liberia, or Panama, or Cyprus. They do that just because it's Liberia, especially, is set up to register ships in their location. You can hire crews from wherever. You'd have crews of Filipino, Chinese, a lot of Indian crews you see on these ships nowadays. Relatively low labor cost countries. The Liberian flag is kind of interesting. Their maritime laws were written up by some New York admiralty lawyers, so it's kind of conducive to making the operation simple.
Inexpensive.
Less expensive. I never sailed on. I've operated a couple of ships that were bulk carriers. loaded grain on the tanker a couple of times, and kind of an interesting experience. Ship's life is about 20, 25 years, so this tanker, the first one I did was a crude carrier, and we're going to scrap it, not scrap it in the United States, we're going to scrap it in India. So to make some revenue on the trip across, we had a grain cargo that we're going to load here in Portland, as a matter of fact. So you spend a couple of weeks cleaning the residual oil out of the tank, all of the tanks, and you then bring it to the terminal. Terminal looks at the oil tanker and says, okay, how do we get the cargo into the tank? Because the deck of an oil tanker is pretty tight. You have, for each tank, you might have 16 tanks on an oil tanker, and each tank only has one tank access for a human being. It's an expansion trunk. It's probably 3 feet wide, circle up in diameter. And then you also have some Butterworth plates. Butterworth plates are used for cleaning the tanks. You put a hose down there, but the Butterworth plates are relatively small diameter, maybe 16, 18 inches. They vary a little bit. So we get, this is the first time we're doing this, and get to the terminal. The supervisor comes on and says, okay, what do you do with this? And I said, well, we can open up the expansion trunks, we can open up the Butterworth plates, and you can take your spout, which is probably 2.5, 3 feet wide, and maybe 18, 20 inches long, something like that, and try to fit it in. So they put spouts in. So to make a long story short, it was a big hassle. They don't see these tankers often because they're accustomed to a large, wide open hatch on a typical bulker, and we also had to, their spout would only get to the center tanks a little bit, but we've got only the onshore tanks. So after we loaded as much as we could in the wing tanks and the center tank, we had to get tugs, turn the ship around. Expensive. But we ended up making a little bit of money on the deal, so it wasn't too bad.
Sometimes you see them down in Palermo where they have all those grain loading facilities. They'll frequently have a front end loader down in the cargo hold, shoving grain to places where they can't reach.
So question, how do they unload that quickly?
How do you unload? You can unload it with conveyor belts or evacuators, like a big fan that sucks the grain out,
Right.
and then it goes into a terminal.
Okay.
So
Serious shop vac.
Yeah, great big shop.
Yeah.
Sort of like that.
Yeah, so actually I didn't go into too much of that. So yeah, the grain ships that we see, the bulk ships that we see here are to load grain, but on bulkers worldwide, you'll load ore, coal, you can put logs on them. My son's a pilot up in Alaska, and I was just talking to him. He took a bulker that was into Anchorage that discharged cement. They're going to discharge the cement, then come to the west coast someplace and load logs and take the logs back to Korea. After that, they were going to take more cement from Korea, bring it down to Australia, go over to New Zealand, and load more logs for China. So these ships tramp around. Let me see. Oil tankers. Most of the oil tankers we see here in Portland are clean product tankers. They're relatively small, carry about 40,000, 45,000 tons of oil. There are no refineries in Oregon. So our refined products all come from refineries, about 90% from refineries up in Puget Sound there. There's a couple of big refineries in Anacortes. We see two up there in Anacortes, one up in Cherry Point and one in Ferndale.
Which is the one in Blank?
BP is in Cherry Point. That's in Cherry Point, yeah. So we used to run into there. There's also an Olympic pipeline that delivers refined product from those refineries in Washington down to Oregon. But I don't really know the economics of it. Maybe at certain seasons they can't get enough gasoline. Maybe in the summertime a lot of good, but you will see tankers coming into the Portland area. So a majority of the gasolines, diesel, jet fuel, clean products come through that pipeline. Yeah. Oh, there's also some controversy about this. Some crude oil comes down the Columbia by train. There's a transport terminal here, and that crude oil is loaded onto ships and taken to West Coast refineries. A lot of it goes down south to the Long Beach area. Refineries down there. So propulsion system on a tanker. I might go with the tanker too. I'm not sure. I haven't finished this one. More bulkheads. So the propulsion system you see on a tanker very similar to a bulker. You have a single diesel engine, slow speed, turn about 85 RPM, something like that, burning a residual oil. And yeah, you make about the same speeds, 15, 16 knots. Difference between a tanker and a bulker. On the deck of a tanker, you see a lot of piping. Piping for cargo oil to go off. You'll see we have inner gas systems on there. We have fire mains and all of that. So when I first started sailing in the early 70s, if you wanted to load a tanker, it was open loading. The tank top would be open to the atmosphere. If you wanted to know what the ullage, the height of the liquid in the tank was, you simply went to this little ullage cap on the top. You looked in there and you saw what the ullage was. You drop a tape down if it was getting close to the top. Yeah, or daylight. We used to use, you have a flashlight also, but daylight we would use reflectors to look into a dark tank. You get the sun, and much better than that flashlight. You get the reflection of the sun into the tank, and you can see great.
Bill, maybe you were talking. He said diesels, and technically speaking, a diesel engine is anything that operates on compression. But these diesels are so different from what you're thinking about. Bunker oil.
So it's a heavy residual oil. It's a black oil. Looks like what comes out of your crankcase when you change the oil in your car.
No,
but
it's worse than that. It's worse than that. It's half dirt.
Well,
You
if
get
do
it
your-
stained on you. It
You
stains
do your sister's car and she hasn't had the oil change in about 3 years or something like that. It looks like that. Yes, it's heavy. It has to be heated before it goes into the engine. It goes in the engine under pressure. And,
Isn't it so polluting that you can't use it within 25 miles of the coast or something?
Big changes. I was going to talk about that at the very end, but this heavy residual oil, years ago, 10, 15 years ago, 4 or 5% sulfur content. Now you can't use oil that's got anything more than 0.5%. So there's been big changes in the quality of the oil. They're also switching to MGO, marine gas oil, which looks, just like a diesel oil. It's a light color oil.
Bill, in profile, it's real easy to tell a grain ship from a tank, because the grain ships got like that. But they all have the red, black, white. Why the color scheme?
Well, they don't all.
No, but that's the classic look.
Yeah, you
Right.
see blue. Yeah, the red is an anti-fouling, typically ablative type anti-fouling. Used to use tin. Tin's been outlawed now. Now they're going to copper, and I think there's eventually we're going to get rid of copper too for the anti-fouling. Then you'll see a blue topping above that, and then the whole pink. As far as the colors, there's a large company, bulk carriers, or Pacific bulk carriers or something. You see them downtown at the grain terminal, Louis Dreyfus terminal. Big blue.
Blue,
hull,
right? Yeah. Okay. Yeah.
Blue, bright blue. And, so yeah, there's no real reason for it, but typically the anti-fouling is real.
Boot top is actually formulated for mixed exposure, so it's a special kind of paint. Traditional anti-fouling needs to be underwater all the time, and that they violate that when they come into port, but all the time at sea when they're in ballast.
Okay.
The red part is underwater. The black part is where the water line goes up and down, and then the color above it is immaterial, whatever strikes the fancy.
So U.S. and international regulations now require all tankers to be double hulled. A lot of bulkers are double hulled also, but tankers are required to be double hulled. That came about after the Exxon Valdez in 1989. Ran aground at Prince William Sound, spilled a tremendous amount of oil. And Congress got to thinking about that, said we've got to stop this. So they came up with the Oil Pollution Act of 1990 and put a lot of changes to the industry into effect, but primarily double hulls for oil tankers and barges. You weren't required to change immediately. There was a phase-in period for the size of the ship and the age of the ship. So, but by now, all tankers and barges are double hulled, which is good. So. And the Oil Pollution Act didn't invent double hulled ships. There was a class of ships that Chevron built here in Portland, I believe, that were double hulled, and they built them in the late 70s, early 80s. And actually, I've been involved in double hulled ships that were built in the late 70s, also some larger ships, 120,000 deadweight ton. So yeah, the double hull was not an invention of the Oil Pollution Act. They've been around for a long time. Why Exxon didn't put a double hull on the Exxon Valdez? The ship was built in the mid 80s, I think. It wasn't that old, early 80s. So yeah, it was interesting.
A lot of the engineering analysis said that wouldn't have made any difference. Because the problem is if you're building a steel structure, you build a hole, you build another hole, you got to keep them apart and build structure that. So when you run onto a reef, if you rip a big enough hole, you also poke all those tinker toys on the inside through the inner hole. So it was the analysis said that double holes would, I don't know, it was like 40. They would make a significant difference in oil spills 40% of the time. So. A big enough ship.
Good thing. I was involved in the ship that didn't run aground. It came down on its anchor here in Huntington Beach, sometime in the early 80s or 90s rather. So the ship was maneuvering into an offshore terminal to pick up a hose, and as they came into the terminal, it's interesting mooring arrangement. You come in at right angles to where you want to be when you're finished. You drop the port anchor. Turn the ship, and then you're back into the, it's not a slip, it's a set of buoys that hold the ship in one place. And there's a hose, a submerged hose that you pull up with the crane, the ship-borne crane. So as the ship was maneuvering into the dock, or into the mooring, drops its port anchor, turns 90 degrees, and what we found out was there was a lot less water at the depth of that berth than was on the chart. By 7 or 8 feet. They hadn't done soundings in quite a while. So as they returned, swell came, ship came down, and we put the anchor right through the bottom of one tank, and immediately, it was a single-hull ship, immediately 5,000 barrels of oil went into the water. And so that's one case where a double hull would have been great. It didn't really function that much. So there's pros and cons, like Mitch was mentioning. Also, you run a double hull tanker aground, you're going to flood that void space in there, and it becomes a more difficult salvage challenge to get that off the rocks, because now you've got water where you had buoyancy. So, another type of commercial ship you see car carriers. So right down the river here, we see a big car carrier terminal. Car carriers, they are distinguished by a lot of freeboard. Because cars are not very dense. When you put a car carrier on a ship, it takes up a lot of space, not a lot of room. There's space under the chassis and everything like that inside. So yeah, they're distinguished by their freeboard. They're also ugly. There's just no form to them. It's just a big box with flat sides. Yeah, it's just
so
terrible.
I've always wondered about car carriers. They look unstable. Do they use stabilization?
They have ballast control. Speaking of stabilization, because of ballast, I'll just briefly talk about this. When a ship comes into port, empties all its cargo, it has to replace that weight with something, ballast. Not one for one, but you have to put some ballast on it. An empty ship with the machinery all the way out, which is where I'll put the big diesel here. Bow with no cargo, bow's going to come pretty much out of the water, and the stern comes up also because the propeller will have no water. So you have to put ballast in any ship to go back to sea if you have no cargo. So this was an issue like 30 or 40 years ago, I started hearing about zebra mussels, I guess, in the Great Lakes, because ships would load the ballast, take it on as they discharge cargo, then they come to another port, they discharge the ballast that they had picked up in the previous port, goes into the local environment, and you're having invasive species that were causing all kinds of problems. So, back to car carriers. So to prevent the transfer of ballast, what we were doing was, for years on ships, doing ballast exchanges. You'd take the ballast where you needed to in port or inside the dock, and then when you got out to sea in deep water, you discharge the ballast and replace it with seawater, which still has some organisms in it, but a lot less than what you had in port. So car carrier, this is probably 10, 15 years ago, was doing this ballast exchange here in the North Pacific, and they didn't have a lot of cargo on board, and somehow they miscalculated their ballast tanks as they were doing the ballast exchange. Probably got too much ballast water out of the tanks before they put some in adjacent tanks. And yeah, a little top heavy, and it tipped over. It floated, and there were some cars still on it, but it floated for quite a while before they towed it into port, and then eventually pumped the water out, got it righted, and so yeah, stability is a big concern on a ship like that. Nowadays, they have computers that calculate, you put the weight of the cars in there, and you can avoid having issues of tipping over.
Stability is a lot more complicated subject than it seems. As a captain of a ship, one of the trainings that Bill's been through much more than I have, but you have to understand ship stability. And there was a video that was made in Holland of a big ocean-going barge being loaded with forklifts. And you see this, it's a time-lapse thing, it's just a security camera film. And you notice that the forklifts are rolling on and off, and this thing is starting to roll. And it's getting slower and slower and slower. And the guys drive their forklifts off and go to lunch. And an ocean-going ship with a wake about that big goes past it, and this barge goes.
Yeah,
No, it's just miscalculation. It was, a barge is an incredibly stable vessel, just flat bottom. But failure to completely calculate the effects of what they were doing.
Yeah, so years ago, it was very difficult before computers, like in the 60s and 70s, to load a general cargo ship. You'd have tween decks and have weight there, and big job for a chief man. I never saw a chief man on one of those ships, but you'd get the weight of, you might have automobiles or trucks on an upper deck. You'd have maybe some lighter cargo down below in the hold, and so calculating the stability of that, it was quite a puzzle. But car carriers also, they have a number of decks. They'll have 12, 13 decks, so you can have some issues like that if everybody decides to drive the cars off the lower decks, and before they remember to, we got a bunch of cars up on the upper decks, so we're going to have an issue.
I always wondered, are those cars tied down inside the ship?
They are lashed down, yeah. They put straps, 4 straps, 2 forward and 2 aft.
That's a lot.
Yeah,
That's a lot of
So, car carrier would come in. Yeah, this car carriers can carry up to 8,000 cars. So you load a car, say, load a car carrier in Japan, put 8,000 cars on it, strap them all in, because that's very important. And they're parked with 4 inches apart, and then 6 or 8 inches from, since they got front to back bumper. And the decks are low. Decks are, some of these car carriers have decks of varying heights so that you could bring minivans into one deck and fill up the space. Some car carriers have decks that are elevated. You can adjust the height on a couple. We operated one car carrier for a while, and took a short trip on it. And, it was interesting. We're going to carry sedans, so the deck comes down, and then the next trip, minivans, and the decks kind of go up. So,
Need a lot of short drivers?
a lot of short drives. Yeah. Squeaking. Yeah, it's, and then watching them offload. They'll offload these cars, 400 cars in an hour. Yeah, So a lot of stevedores, a longshoremen, same thing. Will get in a minivan and drive off the ramp. All jump out, they grab their keys, and the keys are left in the car, and they just drive them down, put them in the big parking lot, get back in the van, back on board, and just hustle back and forth. Car carrier is probably a little bit faster than boat ship. Probably see 18, 19 knots on a car carrier, more valuable cargo, the faster the ships will go typically. Oh yeah, if you pass a car carrier, if we're rowing or sailing or whatever we're doing on the river, and there are offloading cargoes, you'll hear a big whirl of fans. So ventilation is a big deal. You've got all these cars, getting started in this very small space. So you need a lot of ventilation. Container ships. Let's see. So you don't see a lot of container ships here, I guess because of some union disputes about connecting the reefer boxes to the electricity. They pulled out altogether for a couple of years, but they are back now. So we have 2 samples of containers right here. These are 40-foot containers. In the wintertime, this is a refrigerated container. Some of the wall containers that some of the containers these people built or purchased and put up here are refrigerated containers. You see a little machinery back there with a fan for refrigeration. Let's see. Oh, so interesting thing about containerization. So it started in the 1950s. This guy, Malcolm McLean, who was a big truck operator, he owned a big fleet of trucks. He looked at the operation for loading and offloading ships, and he said, "We've got to do better than this." And it's probably going on for hundreds of years. A typical ship, a cargo ship, before containerization would have 2 booms. You'd hoist them out of their cradles. One boom would go over the hatch. One boom would be swung out over the side. You'd have a runner that would connect the ends of the 2 booms. So by paying off on the winch control on this side, you could swing the hook over onto the dock. So cargo would come on pallet by pallet. You'd have 6, 8 stevedores, longshoremen in the hold, taking the boxes or cargo off it. You have an equal number of stevedores on the docks, so pallet maybe 2 tons of cargo each hatch, one at a time. Very slow process. So he said, "Hey, what if we, load the container at the factory, put it in a container that can sit on the dock. They're watertight. You don't need the big warehouses that we have at these docks." And load it. And it made a world of difference in shipping. Much more efficient. Ship can come in, load a number of containers, 20 tons at a time, 30 tons at a time. Have 4 or 5 different holds simultaneously with these big cranes, and the ship could then sail within a day or so. Otherwise, they were loading for a week at a time. So
also on the eastern seaboard, they had huge amount of depth for containers, and even after containers, they had depth. Depth was rampant on the eastern seaboard, and I was told that sometimes they would bring in high-value products, and half of it would disappear.
I remember hearing 10% of the whiskey that came through New York get filtered. They just write that off. It was so not just there's a bunch of East Coasters here. So
Now they steal a whole container.
That's about it. Yeah, but just made the shipping operation so much more efficient. And I saw this reduced shipping costs by 90%. So suddenly, to ship a box of whatever from across the Pacific, you're reducing the cost 90%. It changed everything.
But until recently, I think it was about 2016 or 17, Panama opened their new big canal. Until they did that, there were a number of, there were a lot of container ships they called Panamax, they're 720 feet long and they're 100 feet wide, because that's as big as you can get through the canal, the old canal lines. But then there were beyond Panamax, which were the big container ships. They would pull into the Pacific side in Panama City, offload containers, put them on a train, take them to the Atlantic side, put them on another container ship of similar size, and it was still less expensive, less lost cargo, considerably cheaper to do than going around.
Because going around is a big round horn.
Yeah, it's a big round.
Yeah.
South America's a
South
big
America's
place.
a pretty big
It's
place.
big weather down there too.
Yeah.
But now with the new canal, all of those big container ships can go through without ever unloading, which, addressing the issue of stolen cargo. Every time you take it off a ship and put it on another one, some of it doesn't get there. There's a lot of stuff available in Panama and in the shops. Fell off of a container.
Wouldn't container ships also affect offshore manufacturing too? Because you have half the cost for shipping.
Oh, yeah, sure, yeah. It became much more affordable to buy goods from overseas. So the whole globalization business was, shaped by that. So, yeah, just to Panama Canal, the old locks were about 105 feet wide. So that was the Panamax ships with, had to be built being less than 105 feet. Now it's up to about 160 feet, something like that. The new set of locks that are adjacent. The old locks are still there. They didn't replace the old locks. It's just a whole new set of locks. So you can get these larger ships through. Okay, so in addition to car carriers, tankers, and container ships, you'll see some tugboats here. Two types of tugboats. Some tugboats do ship assist work. They assist ships on and off the dock. These tugboats typically have a more conventional pointed bow, and they've got all kinds of fancy propulsion now. They'll have thrusters that these tugboats can go sideways, thrusters forward, thrusters aft, whereas 30, 40 years ago, you just had a fixed propeller, you had a twin screw maybe, which was a big deal. And but nowadays you'll see these boats moving sideways, with just as much pull as they would if they were just fixed. So pretty fancy. The other type of tugboats you see are tugs that push barges. They'll have a flat bow across there so that they can get up to a barge, put some wires across, and push the barges up and down Columbia or Rock River. So yeah, you wouldn't take those push boats out in the ocean. So one other thing, as you're sailing along the ship, you'll see draft marks, which indicate the depth of the water that the ship is down. At the midship area, right around where Stu is, you'd see a circle on the side of the ship with a horizontal line through it. It's what we call a load line or a pencil mark. That shows, so that circle, there's a horizontal line through it, and you'll have two letters on either side of the circle. You might see an AB for American Europe shipping, or a LR for Lloyd's Registry. So those letters indicate the classification society that's assigned the load line. So load lines, they were started in the UK by this fellow Samuel Plimsoll back in 1875. So up until that time, they were losing a lot of ships at sea because the owners would want to put as much cargo as they could on the ship, reduce the freeboard, ship would get out to sea and it would start to take on a little water, lose the ship, lose the cargo, and more importantly, lose the sailors in some cases. So, looking at that, I was thinking, 1875, there was a lot of shipping going on before 1875. It took a while to get around to that. So, it's unfortunate. But anyway, so you'll see this mark, the circle with the AB. Actually, this container has a sticker on it from the classification society. It's Bureau Veritas, which is the French classification society. So you'll see a BV on there.
In case it falls off, I mean.
Leather. Well, it probably wouldn't be classed any longer after somebody cut the hole in the side of it. Probably not.
Well, there's a standard because they stack these things. I don't know, 1500
containers? Yeah, I'm not really sure.
Yeah. Anyway, they stack containers extremely high, and these big square posts in the middle have a standard locking lug. So there's a lot of standards that every container has to meet in order to be able to, because they lock them all together, lock them down to the deck, and they're stacked up extremely high. So, the middle of this container is relatively weak. I mean, for our use, it's plenty strong, but for stacking things on top of them, this one is rated, I think, at 77,000 pounds, if I remember right. Something like it. It says on the front door. And if you think about those things stacked 10 or 15 high, you're talking serious weight.
Just to mention something about that, after they stack it, they lock them with these locks, like you described. They do put wires up to secure them, but in storms, container ships, not often, but occasionally, will lose containers right over the side. And that's becoming more of an issue because it's a hazard in navigation. Also, insurance companies, you see the cargo go over the side. It's not really good if they find it. Yeah.
Speaking of container ships, Bill, you alluded to when you go past a car carrier in your little boat, container ships in particular. Where do you lose sight of what's in front of you?
Yeah, it depends on the trim, of course, but it's hundreds of feet, maybe even 1,000. Tankers, I think we have a diagram of that. It was about 1,000 feet. So, yeah, you don't want to, especially in a sailboat, too. You can have a nice wind and you're getting close to the sailboat, and the freeboard on the ship will change the wind dramatically. So I've seen people come in, pass behind you, and then all of a sudden the wind gets very squirrely. So it's not good to sail too close to that ship. That really can't stop anytime. So,
Officers, for a long time, officers were not required to be licensed. The captain often was not the sailing master. There was a sailing master, and the captain was basically a businessman, a clerk.
Yeah.
And they were losing so many ships, and I think it was around 1860, Lloyd's pushed through that they would not insure ships that didn't have licensed officers.
Yeah.
And that was a big change in cutting down the number of loss. The other thing they pushed through was the Lloyd's registry, because a lot of people in that same time period were building ships of green wood, and the ships would deteriorate very quickly. And Lloyd's put in regulations. Now, first ones actually encouraged cheaper ships that would fall apart, and then later on they improved it to the point where it actually encouraged people to build ships correctly.
Yeah, so actually just talking about classification societies, like I mentioned, in the United States we have American Bureau, Lloyd's Registry, Bureau Veritas. So if you want to build a ship, and you want to get it insured, you're going to have it classed to one of these classification societies. So you bring your design to them, they approve the design of the ship, they check the stability of it, they approve all the equipment that goes on it, and they also determine the scantlings, the hull thickness, the steel, the type of steel you're going to use to build your ship. During the construction process, the classification societies have an inspector attending all the time, looking at the whole operation, making sure the welding was done right. They probably sample welds and test run equipment. Then after the ship is delivered, classification societies keep it in class by attending on an annual basis, at least, if not more often, to inspect the ship, see that the equipment's being maintained properly. Dry docking intervals, a brand new tanker, you have to dry dock it twice in 5 years. You can get a waiver by having an diver do an under inspection, but at least once in the 5-year period, you're going to have to dry dock. So, speaking briefly about dry docks, there's dry docks here in the Portland area. There's a big dry dock here in Swan Island, a couple smaller ones for tugboats. Floating dry dock is basically a barge with a sidewall on it to handle lines and things like this. So before you're going to dry dock your ship, you'd send the shipyard a diagram, a drawing of where you want them to place the blocks When everybody's satisfied that the blocks are in the right location. So a block is a concrete block that's portable. You lift it with the forklift and move it around. On top of the concrete, you have some wooden, thick wood, oak or whatever, to cushion the weight of the ship as it comes down. So you get the blocks located, then they flood the tanks on the floating dry dock to a depth where the ship can come in, and then they pump the water out, and as they pump the water out of the barge, the ship lands on the blocks, and they keep pumping until the blocks are out of the water. Blocks are typically not high enough. I'm 6 feet, and you're doing inspection. The blocks are like 4.5 feet, and you start to look at a ship that's like 900 feet long. It's tiring. Yeah. And, but another type of dry dock is a graving dock.
Yeah.
Graving dock is different than a floating dry dock. It's dug into the shore, so you have a caisson or a big door there, and it has a slight angle to it so that the water drains out. But they're the same thing. You set the blocks, you have the door closed at that time, then you have pumps to pump the water into the graving dock, fills it up with water, open the door, ship moves in. It's brought in very slowly by lines to the shore on either side. You get it positioned. Yeah, they'll do a laser scan because very important to get the ship to come down on the blocks as the water is down. The ship comes down. If you're off a little bit, you're not on the frame or on the keel, you can upset the steel.
Hunters Point in San Francisco has a graving dock.
Yeah.
I've worked on the Enterprise in the graving dock
Yeah,
there.
San Diego's got a graving dock also. The majority of them are probably floating. Right?
And it's really amazing if you've never seen it. You've got this big, huge, wide ship and it's sitting on a row of blocks, not falling over.
Yeah, it looks a little scary the first time you do it.
Yeah, but you go down there, you're looking up this big thing over you, and you're like, holy smokes,
Yeah, the floating dock could be dangerous because you have it floating, all the ballast out. If someone opens a valve or something like this, or it starts to leak, the ship is going to come down. If the
that's
valves
the
on one side of the ship,
It could
floating
happen.
dry dock could happen. Very rare, but it has happened. There's a big accident in Dubai on a graving dock. They were doing some work, so the ship was in the graving dock. The graving dock is dry, it's pumped out. They're doing work on the ship, and the door holding the seawater out failed. They had been doing some work, or they were doing some work on it, and somehow the door holding the water out, the caisson collapsed, and suddenly you have water coming 30 or 40 feet up into this graving dock. Killed something like 38, 40 people. And that was years ago. But so yeah, it can be very dangerous. There's a tremendous rush of water. And when a ship is in a graving dock, you're opening up everything. You have a number of sea chests. So suddenly this water would come gushing in. It would flood the engine room. People working in the engine room. There might be people inside the sea chest.
What's a sea chest?
Sea chest. Sea chest is an opening through the hull. I'll put one in my boat here. So you have cooling water. You need cooling water on a steamship. You need cooling water for condensers. On a diesel ship, cooling water running through the engines. You have a lot of them. You have sea chests for ballast tanks when the ballast comes in. So a sea chest is below the water level to take into pump into.
You do it to keep the skin of the ship smooth, so you don't have just a plate that covers the sea chest. It's just a box that goes into the hull, and then on the box, they put as many valves as necessary to tap off water. It'll be covered with a plate that has a bunch of 3/4 inch holes or whatever, all brick, so that water can get in, but fish don't.
Yeah, you have a big screen over it. And then in the shipyard, that's one of the things. You have to clean out these sea chests because there's all kinds of vessels and clams and everything like this. A lot of power stuff after a couple of years.
You sign up for the new guy.
Yeah, very small job. Yeah. But all right, so we covered ballast water, the ballast exchanges. Yeah, just one other thing environmentally. Ships produce or contribute to a lot of greenhouse gases and other gases. I mentioned the fuel oil over the last few years, 10, 15 years, is getting better, low sulfur. They're looking at a lot of different things. They're looking at diesel engines that can run on natural gas to reduce the amount of carbon dioxide that goes into the atmosphere. Some ships are already capable of switching over to natural gas. And they're putting, Mark and I were talking, they're putting sails on ships. So some of them are not traditional sails. There's one design, it's a cylindrical tube sort of that goes up and it spins and it creates pressure differential. And yeah, so this is beyond the experimental stage. They're putting these on some large bulk ships. So they've done enough testing to feel confident enough that they can get some benefit out of this. And that's interesting. And one of the last thing I'll mention is they have a kite system. And Airbus, engineers that have worked for Airbus, the French or European manufacturer of airplanes, they spun off a smaller company and they have a kite system. And they've actually done a test on a ship at 5,000 tons, so fairly substantial, probably 250 feet long. And this kite goes off the bow. So it's not a sail. No part of the sail is attached to the ship. It's attached just by you, like you fly a kite. Instead of single string, you have four to the four corners of this kite, large rectangular. And they have it designed so that it'll fly in a figure-8 pattern, and it increases the speed. So, you know, the speed differential, an airplane wing, you know, the balloon force, so you have less pressure on the upside of a curved wing. So this curved kite flies back and forth in this figure-8 pattern. They said it goes about 60 miles an hour, so it creates a lot more lift, or pull, actually, in this case, not so much lift. And there's a video. Yeah, I think I have a name. It's kind of interesting. No, I didn't write it down. But anyway, if you look for kites,
Kites pulling ships.
yeah, I don't know, maybe you get it, but it's a French company that's doing this, and so they've convinced some other larger bulk ship is going to put this on, I think, like 100,000 ton ships. Having sailed on merchant ships and sailboats, I can see a lot of problems. you come into a squall and nobody's paying attention, everybody's doing something else. And this kite goes into the water, your ship is still sailing along, and this kite is a couple hundred feet away, and suddenly it's a drag, it's not helping you, how do you get it back on board? And it's going to work. The wind is blowing in the right direction, wind comes around from the bow, and suddenly this thing is draped across the front of the ship. And it's like, okay, yes, send a couple of guys to pull this thing, it's like 300 feet long. And,
What's the altitude?
it's a couple hundred feet. There's a video I saw. Yeah, I'm sorry I didn't write that down.
Must
I
have
worked
had
on
those
it.
spectrum
Didn't transport
type
it.
lines on it.
Yeah, with
Yeah.
4 lines on it, and
Yeah.
it looked like it was 200 feet from the bow of the ship, with this kite flying back and forth. It was pretty interesting. But, they said it was working. They were looking at getting 16% reduction in fuel. So that's substantial. Yeah.
So if anybody in the ship
Yeah,
ever
right.
asks if it's time to reach, the answer is always yes.
Pull that thing down. Yeah. Yeah. Yeah, you want to pull it down if we've got the port too. But anyway, that's it for merchant ships.
Well, a couple other ships, yeah, you're not merchant ships, but you'll see cruise ships down in the dry
Yeah,
dock.
cruise ships are coming.
The Coast Guard has some dredgers. I worked on
Yep.
the Essions.
Yep.
You see military ships on the Columbia. There's a really interesting book for the San Francisco Bay. It's a Bay Watcher's Guide to Ships, and it goes through every kind of ship you'll see on the bay. Someone should do it for the Columbia River because there's actually a huge variety of ships. You know,
Yeah.
the barges, your tugs, your military ship, your cruise ships, your boat carriers, your oil carriers.
Yeah, dredges are very
This
important.
is a busy river.
Yeah, because commercial ships will figure how much cargo they can have based on the depth of the water. So the Army Corps of Engineers has got the responsibility to keep that dredge. So if it starts silting in, it's their responsibility to keep it down because otherwise the ships lose revenue and that becomes a big problem.
I was on a Holland America ship, this cruise ship. They had 4 large electric motors on the back motor one, so no through hull.
Yeah, and thrusters, right? They can azimuth thrusters. Interesting thing about thrusters. I was talking to a fellow that was doing some teaching on a simulator in Florida, and a buddy of mine. And these cruise ships had thrusters on the bow that could produce about 28,000 horsepower. At the time, we were operating tankers that were 900 feet long, 190,000 tons. We only had 28,000 horsepower pushing the whole ship. That was all of our propulsion. And they had this much horsepower on the bow. And so cruise ships in and out of port every day. They don't want to depend on tugboats. There's a lot of freeboard on a cruise ship also. So in a breeze, you need a lot of power. So these thrusters are connected through a computer. So in some cases, something like a joystick.
We're sitting in the anchorage in St. Thomas, the popular sailboat anchorage. It's right next to the cruise ship terminal. The Sovereign of the Seas, which is the biggest cruise ship in the world, comes into St. Thomas. They get ready to do a 180-degree turn. They turned on their thrusters, and my boat and half the other boats in the anchorage all dragged up toward the shore. Everybody's scrambling around in their underwear, pulling up their anchor, trying to get out of there.
Yeah, my son sees a lot, up in Alaska, sees a lot of the cruise ships in the summertime. He says they're just gorgeous, but all kinds of propulsion. Excuse me. All right, that's all I got.
Mitch.